Good morning, mathematicians. Today we'll be doing lesson 10.5, Frieze Patterns. The objective today is to guide the application of reflections, rotations, and translations. So we're going to look beyond reflections and also learn about rotations and translations. Let's get started with our warm-up. Here we have a pattern with a circle and a little dot on the circle in various places. So you'll notice the first spot, it's on top, second, it's on the right, third, it's on the bottom, fourth, it's on the side. I want you to turn and talk to your partner about what the shape will look like when it gets to the 9th position, and then how did you know that? Go ahead and do that now. At the 9th position, the shape would look back like it did in the first position with the circle and then the dot at the top. How did you figure that out if you got that for your answer? Now let's review some of our symmetry work from yesterday. We know that a shape is symmetric if you can fold it in half and the sides will line up exactly. And then the line that goes right down the middle is our line of symmetry. For shape I, we could draw a line right down the middle because if we folded it in half on that line, both sides would match up. We also could do the same from this corner to the middle of the opposite side. If you folded it in half, the other two sides would line up. And we could do the same from this corner right here to the middle of the other side. So far we're at 3 lines of symmetry. But I also see 2 more corners that I could do. So here's another one from this corner down to the middle of the opposite side. If I folded it, would it match up? And then from this side, this corner, all the way to the middle of that side. So for shape I have 5 lines of symmetry. And if you'll notice, I have 1, 2, 3, 4, 5 equal sides. Now let's look at shape J. Shape J is a regular pentagon. It has 6 sides and 6 equal sides and 6 equal angles. We could start out by making our first line going through from top to bottom in the center. If we folded that in half, both sides would meet up. And again, we could do that from the opposite sides. Oops, that one's a little off. And then we could do the same thing from the corners. So I could line up corner to corner. If I folded it directly in half, it would line up. And I could do the same thing on the other 2 pairs of corners. Okay. How many lines of symmetry does this regular hexagon have? It has 6 lines of symmetry. So one thing we should have noticed by doing this activity was that if you have a regular polygon, which has the same number, or the same length sides and same size angles, you should have the same number of lines of symmetry as the shape has sides. So here our pentagon has 5 lines of symmetry, 5 sides. Our hexagon has 6 lines of symmetry and 6 sides. That only works for regular polygons, though. Today we're going to look at something called frieze patterns. It says, a frieze pattern is a design made of shapes that are in line. Frieze patterns are often found on the walls of buildings, on the borders of rugs and tiled floors, and on clothing. In many frieze patterns, the same design is reflected over and over. For example, the following frieze pattern was used to decorate a sash worn by Mazahua, a woman from San Felipe, Santiago Pueblo, in the state of New Mexico. The strange-looking animals reflected in the frieze are probably meant to be horses. So that's this picture right here. Some frieze patterns are made by repeating or translating the same design instead of reflecting it. These patterns look as if they were made by sliding the design along the strip. An example of such a frieze pattern is the elephant and horse design below that was found on a woman's sarong from Sumba, Indonesia. The elephants and horses repeated in the frieze are all facing in the same direction. So we can see down here that was made by a repeating or translating pattern where the design is just slid along the strip. So we can see this design is repeated over and over again. And in the one above, the same design was reflected over and over. So that's what we're used to using those mirrors. If we look down here, our line of reflection would go right through that flower each time, and that image would be reflected across. Okay, now in that last design, it says the following frieze pattern is similar to one painted on the front page of a Quran in Egypt about 600 years ago. The Quran is the sacred book of Islam. The pattern is more complicated than the two above. It was created with a combination of reflections, rotations, and translations. So you can see here that the flowers in this pattern below are the same size and shape, but they're facing a different direction each time. So here it's facing the top corner, then the bottom corner, then the top, then the bottom, then the top. And the same with the leaves. So down, up, down, up. Today for our work, we're going to finish the following frieze patterns and then do one of our own using a straight edge and a transparent mirror. And on the line for each one, you're going to tell whether you used reflection, rotation, or translation in order to create that pattern. Remember, reflection is flipping that image over and having the opposite image like we had been doing with our transparent mirrors. A translation is where it slides and it's the same image just slid over each time. And a rotation is where that image flips and is facing a different direction each time. So you're going to work to complete these patterns and then do one on your own. Take out your learning journey and make sure you have the date at the top. We're going to make a little change to our learning journey. So we're going to switch Math Journal 280 and 280B with 281. So we're going to do this first. This is our frieze patterns on page 281. And then once you get done with that, then you can move on to these pages, which are multiplying fractions by whole numbers. And then make sure you completed your math boxes. And then activity B is blend space practice I and J, and activity C is blend space practice M. Make it a great day.